Section 3.4, circle. We will see the standard form equation of a circle and the general form of the equation of a circle. Now, when we say a circle, as usual, we have a center here, and we have the collection of points here that are equidistant from the center. So if the distance here is r, and the distance of this point should be r, and the distance should be r, distance should be r, and distance should be r here. So all points are equidistant. We call it their distances are same. So any point, all points are equidistant from C. So we say all the distances of the points on the circle to the center is same, and we call this with r. R is for the radius. So in Arabic it's nisf qutr, nisf qutr or nisf qutr. I don't know exactly, but it has to be like that. Okay, now of course we will think of the circle in the Cartesian coordinate system. So the points are here on the circle, they form a circle, and when you take any point on the circle, let's call it x and y, it's a general point on the curve, I mean on the line. So let's say this center is located in at the point h and k. H is the x component, k is the k is the y component. So if you, and the distance between x and y and h and k is r, so we can write it as by using the distance formula. The distance formula between hy and hk is this one here, x minus h squared and y minus k squared. Square root is equal to r. Or we can take the square of both sides. We can write it this way. So any point, these are standing any point for the, these are the general representatives, ممثل, for the points on the circle. So they stand as x and y stand for any point on the circle. H, K, R, these are just numbers. So these are variables here, and these are numbers here. So you will see it in the examples. Okay, this is called standard form of the equation. I mean, of the equation of a circle. So the standard form of the equation of the circle with center hk and the radius is given by this formula. So the meaning is that this hk, as in the previous slide, so when you take any point xy, a representative point for the circle points, so the distance between any point on the circle and to the center should be r. So the distance, by using the distance formula, we get this one. Now we have some special circles. One is the one located, the one centered at the origin. So here 0, 0, h and k should be is 0. And in this case, when you put 0 here and when you put 0, then you will end up with x squared plus y squared is equal to r squared. So indeed, if you see such an equation, you can directly say center is 0, 0. And another one, a special one, is also this one here. This time it's centered at the origin, but this time an extra condition is this: the radius is 1. So this type of circle is called unit circle, and its formula is now x squared plus y squared is equal to 1 squared. So it's 1. Okay, first let's do this example. Writing an equation of a circle given the center and the radius. So find the standard form equation of the circle with center -1, 1, and the radius k. I mean radius 2. So here you can say this is h, this is k, and the radius is 2. And then we write the formula x minus h squared plus y minus k squared is equal to r squared. So let's put them together. It's minus 1 squared. Y minus 1 squared is equal to r squared, which is 2 squared. So then you can write it this way: x plus 1 squared is equal plus y minus 1 squared is equal to 4. So as you see, I mean, because of this minus issue, we might have plus, but indeed, this having plus here, as you see, it gives the center's component as minus. It gives the x component of the center as minus. Okay, this is one thing to notice, because sometimes we will give you the standard equation for the circle, and from the circle we will ask you to find the center. And now you have to pay attention if you have a plus here or minus here. This is important. This will be important. Okay, let's see how it is done. Okay, we will substitute h, k, and r. Okay, let's look at this example. Finding the center and the radius from the standard form equation. So, for example, it says identify the center and the radius of the circle with given equation. So the question here: what is h, what is k, and what is r? So the center will be hk, and the center will be the ordered pair hk, and the radius will be equal to r. So we will try to find them now. So let's see. So let's use this experience here. If it was plus, we would have minus here. So or you can write this plus as minus, so that we can have this h here minus. So we can do the same thing here. So we can write this one as here plus. You can write this plus. If you see plus, you can write it as minus. So this way we can see this is h, and this thing is k, because it has to be always minus k minus h here. And then the r is definitely, this is 6 squared, so r squared is r squared. You can tell the h is 3, k is minus 4, and r is 6. Now sometimes the center will be given to you, but not the radius directly. So look at this question. The point minus 4, 2 lies on a circle centered at -6, 3. Find the standard form equation of the circle. So it says minus, okay, if you visualize it, it will be better. It will be better to solve the problem. Look here, minus 4, 2 is on the circle. I think minus 4 is somewhere here maybe, or somewhere here maybe. I'm not sure. Okay, so I think it's somewhere here maybe. Anyway, its location is not that important. Here it says, okay, this is center because it says centered at -6, 3. It says find the standard form of the equation. So basically what you need is h, k, and these are given. H and k are given to us, and the only thing is we need the radius. So how can we find the radius? The radius is obviously it's the radius is obviously the distance between -4, 2 and -6, 3. So what we have to do is we have to find the radius as the distance between -4 and 2. And do we know this distance formula? Yes, we know. Okay, let's see how it goes here. So we write the standard form here, minus h is -6 and k is 3, but we don't know r. But the point -4 -2 lies on the circle. So here, and it has to satisfy the equation of the circle. It means when we put this here, it has to satisfy the equation. Or, this equation comes from the distance formula, right? So writing them in the equation or setting the radius equal to r, making the distance equal to r squared, the same things here. You can write here the distance is r squared is equal to -4 minus -6 squared plus -2 minus 3 squared. Is it? Okay, it's 2 here, sorry. So it's 2, so you will end up with r squared is equal to the same thing here. So r squared is equal to 5. Okay, let's be careful. R squared is equal to 5. But anyway, it's asking not the radius, it's asking the the equation in standard form. So we have x minus h squared x minus k squared is equal to r squared. Now, the general form of the equation of circles. Now, this here, we call it the general form of a circle equation. So you can ask this question: where do they come from? Indeed, they're coming from here. For example, take this equation here. When you expand this one, you will get x squared minus 4x plus 4 and y squared minus 6y plus 9 is equal to 4. And then when you send this one to the other side and combine these terms, you'll get this one here. Will be, and you can arrange the terms, you can order them. So you see, like when you expand an equation, like an equation of a circle, then you end up with such thing. So this is the standard form, but this is the general form. So sometimes we will give you the general form and ask you this one, or sometimes we give you the standard form and ask you the general form. Okay. Now, the question here is, how can we pass from one side to the other? So how can we pass? If you want to go to here or if you want to come back, I mean, if this is given to you, how do you know the center? How do you know the radius? So how can we do this passing? And how can you make this transition? So I will explain this in a minute. So general form and standard form of equation can be converted to each other in the following way. So this is the general form. It's given to you. Then you can write x minus, you can write the standard form this way. So what is h, what is k, what is m? But you can use this a, b, c to get them. So h is minus a over 2, k is minus b over 2, and m is a over 2 squared plus b over 2 squared minus c. Or these are given to you. You can say a is minus 2h, k is minus, b is minus 2k, and you can write them here. And as c is equal to a over 2 squared plus b over 2 squared minus m. You can, you can convert by using this. Now, if you ask, where does this come from? Indeed, this conversion comes from this rearrangement. Like this one can be written as, I mean, if you add, if you subtract and add some necessary numbers like a over 2 squared and b over 2 squared, and subtract, okay, c, send c to the other side. Okay, I want to explain it to you. This x squared plus y squared, ax plus by plus c plus c. Okay, I will send it to the other side, negative c it will be. Now the question is, can I make this one, this two of them? Okay, I will write here ax, and I will write here by, and here minus c. And can I make it a complete square if I add something? Okay, how about adding here a over 2 squared, and write here a over 2 squared, and plus b over 2 squared, and this is plus b over 2 squared. And this part, this part will be this, and this part will be the square of x plus a over 2 squared. This will be y plus b over 2 squared. Anyway, you can open and you can expand this one, and you can do some calculation and see it. I will not get into the details. So if you want to, I mean, we can show it to you. But all you have to know is this transition. Now, assume you have you did this, and you change this one to the standard form. There's the general form, and you change it to the standard form. You have some cases here. M might be a positive number. In this case, everything is nice and it makes a circle. And M can be a negative number, or M can be 0. Let's see. There are 3 possibilities for the graph based on the value of M here. M, if M is bigger than 0, so this graph is a graph of circle. It's a circle with center HK, and the radius will be square root of M. And if M is 0 here, so if it is 0, what makes it 0? If y is equal to k and x is equal to h, so the only x and y values satisfying this equality is just hk, so it gives a single point. Or if m is less than 0, so you have something squared plus something squared is equal to minus some value. It's not possible for the real number, so you say the graph does not exist. Non-existent means ليس موجود. Single points, نقطة واحد. Non-existent, ليس موجود. Or ما في وجود, I guess. Okay. Now let's look at this example. Let's consider this general equation, general circle equation. First, we want to show the graph of the equation is circle, and we want to find the center and the radius. Now, to see if this is a circle or not, so we have to change it to standard form. So first, let's write the equation. Then, how to change this one to the standard form. We have to find h and k. So in order to use this h and k, we have to use a and b, c. A, b, c. So what are they? First, a is 6. So, and b is minus 2, and c is 6. And then we use the relation between h, a, and k with b. So h is minus a over b, and k is minus b over 2, and m is a over 2 squared plus b over 2 squared minus c. And now if you use them, so you will see this h, 6, so it will be minus 3, and the minus 2 is here, and then put them together here again with c. C is 6, so you will get h, k, and m. then here we will concentrate on M, because if M is negative, then the graph doesn't exist. If M is 0, it's a point. And we check M is 4, so M is bigger than 0, so it's a circle. So we show now with this, we have shown the graph of the equation as a circle. So now we can find the radius. The radius is square root of M. So the radius is square root of M, which is 2. And the center is HK. H is this and K is this. The center is this and the radius is this one. Now let's look at this try and check example. It's almost same, so we will concentrate on ABC again. So you can follow the steps here. The step 1, what is A? A is -4, the coefficient of X. This is 6, and this is C is -3. Okay, be careful. C has to be on this part. So if C is somewhere here, you have to send it to the other side. And what is H? Step 2, find HK. So H is -A over 2, and K is -B over 2, and M is A over 2 squared plus B over 2 squared minus C. So this H turns out to be 2, like put -4 here, so you will see it's 2. And 6 here, so K will equal to -6 over 2, which is 3. And M will be A over 2, this is H, A over 2 squared, 2 squared plus B over 2 squared. So I mean, I can take the minuses here because the minus squared and it will be positive again. It will be 3 squared here. Minus C, C is -3. So it will be 4 plus 9 plus 3. So this is equal to 16. So we got step 3, M is 16. So it's bigger than 0, so it's a circle then. So this equation specifies a circle. And then step 4 is the center and the radius. Center is HK. What's HK? H is, it was -A over 2, so it was 2. And then K is -3, we know from here. And what is the radius? The radius was, okay, the radius, we know it's a square root of M, which is square root of 16, which is 4. So it's a circle with center 2, -3, and the radius is 4. Okay, so it's again the same type question, but it says this time, does it make a, I mean, determine whether the graph of this equation is a single point or it doesn't exist or it's a graph. I mean, it's a circle or a circle. So we have 3 possibilities. So it's single point or doesn't exist or a circle. So we will use the same idea. We will find HKM, especially M. M is the most important thing here. So first, you do step 1, what is ABC? Then you find A is this, B is this, and C is this. And then use H equal to -A, K is equal to -B over 2, M is equal to this. Then you substitute them, you find M. So M is here, it turns out to be -4. -4 is less than 0, so the graph of the equation doesn't exist. So it's non-existent. You will say it doesn't exist.